welcome Steve.
All right, so as Felix said, we're looking at the effect of police numbers on crime and arrests. This is sort of the layout of the presentation. So first, we're going to outline the two research questions. I'll briefly summarize the literature. I'll go through the data. I'll describe very briefly the run-up to the 1999 and the 2003 New South Wales elections. You'll see why it's relevant soon. Then I'll go through the identification strategy. That's kind of like the design or the statistical approach. Then I'm going to cover through the results. I'll talk about the policy implications, limitations, and there'll be time for Q&A. Also, so there is a bit of a lag, it looks like, so bear with me. Okay, so research question number 1. What is the causal effect of police numbers on crime? It's pretty straightforward. Theory says that police reduce crime, and that can occur through two channels. The first is a deterrence effect. So that is, the police go out and they essentially shrink the fraction or the percentage of the population that offends. The second is incapacitation. So that means they basically just lock them up and they're off the street. Now, it's important to note that both deterrence and incapacitation work to reduce crime, so they move in the same direction. So that's a straightforward question. What's the problem? There are 3 problems. The first is detection bias. So what's the idea here? You increase the size of the police force. They're able to go out and sort of detect more offences. So it looks like there's more crime, when in actual fact the level of crime hasn't changed. Second problem is reporting bias. So it's a very similar idea. The number of police goes up. People then report more crime. So it looks like the amount of crime's actually gone up when really it hasn't changed. And the third problem is called simultaneity, or simultaneous causality. What's the idea here? It comes in two sort of parts. The first part is a dynamic element. So what does that mean? Say crime goes up in period T, then in period T plus 1, so it could be a month, 2 months, maybe a year later, the size of the police force expands in response. When the size of the police force goes up, we go back over here to detection and reporting bias. So that's the dynamic element. And then there's the static problem. So high crime areas tend to have more police, and what that does is it induces a positive correlation between police and crime. So what happens is most empirical studies outside of economics find that police either increase crime or they have no statistically significant effect. So research question number 2. What is the causal effect of police numbers on arrests? So theory doesn't make any definitive claims regarding arrests, and this is why it's kind of the more interesting case. So deterrence lowers the arrest rate. Why? There are more police, there's a deterrent effect, they shrink the fraction of the population that offends, so there are fewer offenders to arrest. Incapacitation, almost by necessity, requires a higher arrest rate. So when it comes to estimating the effect of police on crime, deterrence and incapacitation move together. In arrest, they move against each other. So the net effect is ambiguous, we don't know. And you still have to deal with detection, reporting bias, and simultaneity. So that's the setup. We're trying to estimate the effect of police numbers on crime and police numbers on arrests. So literature, people that have already done this. So all studies that estimate these causal effects convincingly deal with reporting and detection bias by looking at crimes unaffected by these problems. What are these crimes? In general, they are murder, robbery, break and enter, theft, and motor vehicle theft. Now, there are 2 reasons for this. They're both well reported, and that's because victims have a strong incentive to report, and also they're difficult for the police to detect. So that's how we get across the reporting and detection bias problems. You look at these crimes, that kind of knocks it out. So what do we have left? We have the simultaneity problem. So the studies that do estimate these effects can be broken into 4 groups based on how they deal with the simultaneity problem. I'm just going to review my favorite from each group. So, approach number 1, time series approaches. What do? They control for seasonality, they control for pre-existing trends, and then they try to see if an increase in police numbers in one period leads to reductions in crime in the next. So the study I've chosen is by Marvel and Moody, and it's an old one. They find Granger causation between police and crime. What does that mean? They find that an increase in police in one period lowers crime in the next, but they also find that an increase in crime in one period increases the level of police in the next. So So it's not true causality. The second approach is instrumental variables. And I have to say, I'm very glad that Sarah and Suzanne already presented on instrumental variables. Hopefully you went to one of their presentations at least, because explaining it's really hard, and they did a good job, and I'm going to do a bad job. So what you do is you utilize a third variable. It's called an instrument. It's correlated with police numbers, but otherwise unrelated to crime rates. Why is that good? It allows us to isolate for variation in police numbers that is otherwise unrelated to crime, and it sort of breaks the simultaneity problem. So a very cool paper in this literature is by Levitt. I don't know if you've listened to the Freakonomics podcast, but he's one of the dudes on there consistently. And what he does, he uses election cycles as an instrument for police numbers. So what's the idea? In the run-up to an election, the incumbent government, if law and order is an issue, they usually just sort of jack up police spending on police, and they hire more police. And he says that once you control for other forms of government spending on, say, like welfare programs, then you can use an election cycle to extract variation in police numbers that's actually unrelated to crime. So that's the instrumental variables approach. The third approach is called difference in differences. So this is probably intuitively the nicest approach. You have a treatment group exposed to some policy intervention, a control group unexposed, and you compare them before or after. So these guys, Detella and Shkagrodsky, I practiced that. So what do? Their treatment group is religious sites in Argentina. So what happened, I think it was in the early 2000s, a mosque got bombed in Argentina, and then after the bombing, they increased police numbers around religious sites in Argentina. So I think so that's their treatment group. Their control group is non-religious sites, and then they compare before the bombing with after the bombing. And they find a deterrent effect of motor vehicle theft. And then I didn't quite know how to characterize studies in this literature, so I just called it unconventional approaches. Klik and Tabarok use variation in the daily terror alert. So in Washington, D.C., they have a terror alert level that changes daily. On high alert days, there are more cops are out and about. On low alert days, there are fewer cops. So they essentially just compare crime on high versus low alert days. They can only infer the effect of police on crime because they don't have access to the number of police that are out and about for security reasons, and the police won't give it to them. So that's the summary of the literature with the effect of police on crime. When you look at police on arrests, only one study by Emily Owens has managed to do it, and what she does is she takes an instrumental variables approach, and she instruments police numbers with hiring grants allocated by the US Congress. And she finds police have no significant effect on arrests. And what does that imply? That implies that police, at least in the US in the late 90s, are reducing crime through deterrence rather than incapacitation. Okay, so the data that we use in the study is very simple. We look at monthly local area command level counts. A local area command, as you almost definitely already know, is just a police jurisdiction, of police officers, crime and arrests over the period July 2000 to 2005. Why this period? It'll become clear soon. What crimes do we look at? The same ones I said before. So homicide, robbery, theft, motor vehicle theft, and break and enter. Okay, so in the lead up to the 1999 state election in New South Wales, law and order is a big issue. I think I pulled this quote from a Sydney Morning Herald article, and I think Bob Carr said it. Anyway, so at the time, Bob Carr promised to increase the number of sworn police officers to about 14,000, and that's up from about 13,000. So what happens? He wins the election, and then he doesn't do anything, and he just sits on it. Until the lead up to the 2003 election. Law and order is, again, a major issue. I'm pretty sure this is a quote from The Australian. And what happens is in May 2002, so just under a year out from the election, they opened what was supposed to be a temporary police campus in Richmond. And in fact, I'm fairly sure, I'm confident that it was open almost entirely for political reasons. And this is an extract from their 2002 annual report. And the quote says, "Establishment of the additional campus will enable police officers to reach exactly the number that Bob Carr promised by December 2003. So what happens? Later that year, Bob Carr, they meet the election commitment almost an entire year early. They smash it. There are a huge number of police. There was a huge intake in that period. And then so this quote basically just sort of supports that claim. And then in March 2003, Bob Carr wins the election. And then the next month, police numbers begin to fall. Now, they don't fall super fast, but they do begin to drop. And that's what you can see here. Now, the lag is going to be annoying here, so bear with me. So here we've got time measured on the horizontal axis. I've aggregated the data from monthly to quarterly to sort of knock out some of that seasonal variation and things look a little bit smoother. It doesn't affect the analysis. Here is when the hiring campaign begins. This is when the hiring campaign ends. There are 3 time series that we're looking at. The first time series is the solid line. So that's here, that's the number of police. So what is this 100 equals Q3? What I'm doing is I'm indexing all 3 of the time series to the 3rd quarter of the year 2000. So what does that mean? It's similar to the way they sort of look in inflation. They take a base year and they measure it in percentage changes from that. So here you can see that the size of the police force in New South Wales is basically stable. The hiring campaign kicks in and then it jumps up. And then it peaks at about 120% of the 3rd quarter of 2000 levels. So that's how you interpret that. There are 2 other series. So this is crime, just the crimes I outlined before. The long dash series is this one. You can see it's going down. It starts to drop before the spike in the police force, which we'll go into. And the short dash series here is arrests, and you can see the 2 series are obviously related, and it starts to fall as well. So that's just sort of a picture. Okay, so what's the model? How are we going to do this? We do it in 3 steps. In step 1, we estimate the effect of the hiring campaign on police numbers. In step 2, we estimate the change in crime and arrest rates during the hiring campaign. In step 3, we combine the 2 estimates to get the effect of police numbers on crime and arrests. Now, as always, there's an identifying assumption. What is it? The best way to read this is that there's no factor that varies both over time and between lacs that affects crime or arrests during this year. So, I can think of at least one factor that probably would, and Moffat, Weatherburn, and Donnelly in 2005 sort of pretty clearly outlined it. So if we jump back, you can see that here crime rates drop before the hiring campaign. So Moffat, Weatherburn, and Donnelly, what they say is part of the reason for the drop is because there was a heroin shortage in New South Wales. Now, heroin availability is likely to vary between, like geographically, between local area commands and as well as over time. So that's a potential threat to the analysis. How do we deal with it? We take lacs with high use/possess opioid offenses and we just throw them out and we rerun the analysis. If everything looks the same, then it's not really an issue, and that's essentially what we do, and it's all good. So that's one threat taken care of. So step 1, math. Forget this ln. PIT, that's the number of police officers in LAC I at time t. So it could be the number of police officers in the King's Cross Local Area Command in July 2000. Ignore this guy for a minute. This DT over here, this is an indicator variable for during the hiring campaign. So it basically splits our sample in half, before and after. This guy over here, this controls for differing trends in police hiring between LACs. This guy over here controls for the static simultaneity problem, so that's gone. So far we've knocked out reporting bias, detection bias, and static simultaneity. All we need to worry about is the dynamic simultaneity issue at this point. This controls for seasonality common to the entire state. So that could be in crime rates, unemployment, those kind of things. This represents everything we can't see in the data. What do we really care about? We care about this guy. So what is it? This guy is the average percentage change in the size of the police force resulting from the hiring campaign. So that's what we're estimating in step 1. Now there's a lot going on in the table, so stay with me. Only look at this row here. Everything in a bracket is a standard error. These little stars indicate statistical significance. And let's focus our attention on this first column. So what does this guy say here? This says that the hiring campaign increased the average size of the police force by about 7.2%. That's what he says. So what do these columns indicate? If you take the lacs before the hiring campaign and you look at the average size of their police force and then you rank them, so this would represent the top 25% of lacs with a huge number of cops, and this would be the bottom number of cops. Essentially what we're doing is we cut the sample into 4 quarters, and then we see how the hiring campaign affected lax in each quarter. And so here you can see lax with the smallest size of the police force before the hiring campaign got a 4.9% bump, these guys got a 10% bump, and so on. So those of you that are familiar with instrumental variables, you'll see that monotonicity is clearly satisfied because when we split the sample up, we're all good. Also, the first stage F statistics are over here, and you can see that everything's fine, so that's relevance and monotonicity taken care of. If you don't know what those things are, don't worry about it. Okay, so far we know that the hiring campaign affected the size of the police force. Step 2. We're basically estimating the same model, but now we're looking at crime or arrest rates over here, so that's what CIT is, the number of crimes in LAC-I in month T. All this stuff's the same, so this controls for different trends between lax, static simultaneity, seasonality, stuff we can't see. This is the binary variable that splits our sample in half before or after. This guy is what we're actually interested in. So what is he? He is the average percentage change in crime or arrests during the hiring campaign after you take care of all of this. So, again, there's a lot going on here, so stick with me. Focus your attention only on this row here. I'm going to go one column at a time. First column over here, so we want to look here. This is where we just look at break and enters. You can see that there's no statistically significant change in break and enters during the hiring campaign. Here we look at thefts. Thefts went down 5.8% during the hiring campaign. Motor vehicle theft went down 8.2%. Property crime, which is the aggregate of these two, when you sum them up, went down 4.5%. For robbery, no significant change. Homicide, no significant change. Violent crime, which is the aggregate of these two, no significant change. One thing worth noting is that robbery estimate is positive, even though it's not statistically significant, it's not negative, which is kind of weird. So something worth keeping in mind. All right, so far we know that the hiring campaign reduced the size of the police force, increased the size of the police force significantly. We know that crime and arrests fell during the size of the police force, during the hiring campaign. If you're willing to swallow the identifying assumption that there's no factor that varies over time and between lax during that year, then this row here, the bottom row, gives you the elasticity of crime with respect to police. Now, what does that mean? If you increase the size of the police force by 1%, you're going to see a 0.8% drop in theft. If you increase the size of the police force by 1%, you're going to see a 1.1% drop in motor vehicle theft. And if you look at property crime aggregated, a 1% increase in the size of the police force is going to lower property crime by 0.6%. So that's what that's what the estimates tell you. This will all be summarized at the end, so don't worry. Okay, so table looks exactly the same, but now we're just looking at arrests. So we can see that during the hiring campaign, arrest rates did not significantly change for any crime category, with the exception of robbery. In fact, it looks like arrests for robbery went up, and that's what's driving this violent crime change. Now, given what we saw on the previous slide, the positive coefficient over here, I think, or at least my theory, maybe you have a better one, is that in New South Wales, robbery is subject to either reporting or detection bias. So I'm not taking this estimate too seriously. You can choose whether or not, you can choose how you would like to interpret it. The paper is online as of today, so you can have a look on our website for free. It's the plug. And then also, because these estimates here are all insignificant, the elasticity estimates, that is, you increase the size of the police force, how does arrest rates change, looks like they don't change significantly. So you summarize the results. Point number 1, the hiring campaign increased the size of the police force by about 7%. Property crime fell significantly during the same period. We found that a 1% increase in the size of the police force generates a 0.8% reduction in theft, a 1.1% reduction in motor vehicle theft, and if you aggregate over property crime, a 0.63% reduction in aggregate property crime, no significant reductions for break and enter or violent crime. So if you convert the percentages roughly into real numbers, this means that one additional officer stops about 17 thefts and 4 motor vehicle thefts a year, at least back in the early 2000s. No significant effect of police on arrest for these same crimes. Overall, what can we conclude? Police reduce crime through deterrence rather than incapacitation. And that's fantastic because it's much cheaper. So, what are the policy implications of this? I think a fantastic question to ask is, how much should we really pay a cop, right? And so the starting point for that question is the wage cost of an additional officer, is the wage cost of an is the wage cost of an additional police officer offset by the benefits she provides to society in the form of crime reduction? Usually this is a really difficult question to answer because estimating the effect of crime is tricky. If there's an effect on arrest, then maybe you have to weigh in the fact that they're locking more people up, and if a prisoner goes in, that becomes difficult because they're incarcerated and we have to pay for that as well. But since there's no effect on the arrest rate, and we know that crime is going down, we can take a stab at it. So in 2005, a general duties, which is like a street patrol officer, made about 50 grand a year. So using insurance claims data, which we can trust, Mayhew estimated the cost of a motor vehicle theft to be about $6,000 per vehicle. So you stick the two estimates together, and we find that an additional police officer is able to offset almost half of her annual salary by deterring motor vehicle thefts alone, and that's only one crime category. The result is largely consistent with the studies that I sort of talked about at the start. What are the limitations? I'm not sure how well they would generalize to modern-day New South Wales. Why? 3 reasons. First, it's harder to steal a car. Second, I think the offending population is smaller, although I'm not sure. I don't have a reference for that. It's just my intuition. Similarly, there's been a deterioration in the market for stolen goods, so it's harder to resell things. There's less incentive to steal. Second, the police were used to support high-visibility policing operations with the explicit goal of deterring street offences. So if the additional police were used for a different purpose, to, raise the arrest quota, we might see a different result. Third, I only look at a small number of violent and property crimes, so looking at the downstream effects on the prison population is questionable. That said, the study's still pretty cool. It's the first of its kind in Australia, and therefore provides the only guidance to policymakers in an Australian setting, and that's it.
Any questions for Steve?
Yes, Steve, you said that if you increase the numbers of police, that will help in decreasing the crime rate. There's some truth in that, but I think it's more dynamic than that. I think you're looking at the crime rate has gone down because of the proactivity of police officers, and that's managed by the crime managers and the leadership in the police force who actually set taskings for these police officers. So my belief is it's the implementations that the leaders put in to task these police officers to target hotspots or whatever the case may be, and over time that's why we see the crime rate decreasing. So I don't think it's as general as increasing the population of the police force, and that will decrease the crime.
So just so I understand, you're saying that because police are getting more productive, each additional officer can stop more crimes, and that's in part what's driving the effect? Is that roughly it?
Yeah, pretty much, yeah.
I'm on board, yes.
Yeah, so they're not a responsive or reactive police force. It's more of a proactive police force these days. So in the 90s, they used to sit back and wait for the phone call to respond to a job, where nowadays they're out there. High visibility policing actually is a deterrence for crime.
Mm. Would you say that's true for the crimes that I looked at though? So for example, like homicide, break and enter, motor vehicle theft, are they more productive in that respect?
Yep, absolutely. I mean, the crime managers, as I said, the leadership in the police force these days assess their numbers each month and actually look at the hotspot areas and project police officers during that shift to attend those hotspot areas, whether it be break and enters or motor vehicle thefts. We have seen a decrease.
Right, okay.
Sorry.
I think we have time for 2 questions. So,
Oh, his hand shot up so enthusiastically, man. All right.
Yeah, so quick question. I don't know if you would have stumbled across this when you were doing this, because I suppose it's not directly linked, but I wonder if you saw a link between increased police numbers and the number of young people coming even in contact with police or going further, just looking at a more criminogenic cycle sort of perspective.
No. So the short answer is no. The long answer is that I think. So I'm not particularly. So Don would be a good person to ask about that. So my thoughts, and again, I'm not sure. The fracture. So I looked at like sort of specific crimes like break and enter, motor vehicle theft, like pretty serious planned crimes. My intuition would be that young people are probably not committing those crimes in sufficiently large numbers. So the idea is that yes, young people commit those crimes, but like the total percentage of people that are committing those crimes are mostly sort of older people, would be my intuition. So my analysis can't really speak to that, but I could be wrong, I'm not sure.
Thank you.
Steve, this great piece of work, but one important point in the discussion is just that all those crimes are declining anyway. And I'm sure you've done this in your study, but I didn't quite catch, how have you accounted or removed pre-existing trends and other factors to make sure that you're only capturing the impact of increased police resources and not other sort of long-term trends, say for example, in motor vehicles, improvements in technology and other things?
Right.
So how can you be sure that that's police and not other factors?
So if I understand it, your concern is that crime's already fallen, there's a pre-existing trend. How do you know it's the police and it's not just, say, better economic conditions that are driving the effect? And so the answer to that question would be, slides aren't up, so I can't show you. But in the models, I had a lack-specific linear trend. So that that allows for crime rates that allows for different pre-existing trends for each local area command. And then I also included the time-fixed effects, which can sort of control for the passage of time and like sort of macroeconomic conditions is common to the entire state to get better. So those things are taken into account.
So if I can confirm, you used differences in increases in police numbers across the state to, and then correlated them with reductions in crime in those specific areas, and used those differences, those geographic differences in rates, to control for common elements that would have run simultaneously across the state.
So I wouldn't put it that way. I would more say that I conditioned out and controlled for pre-existing trends at the LAC level, as well as seasonality and sort of macroeconomic effects common to the entire state. Those are taken into account, and then I looked at the effect of police on crime. So that's how I would phrase it.